Hey guys, today we're going to talk about a new type of transformation that's called a dilation. And dilations, they're different than what we've worked with in the past because now we're going to change the size of the shape. So we're either going to become larger or we're going to become smaller. Like you start with the shape and then you're either going to become larger like this, or if you went backwards you'd become smaller, but you're still the same shape. You're just a larger version of it or a smaller version. And that just means like you didn't get stretched out, like it became really wide or became really like tall. It means everything changed in the same proportion. So you're getting just as wide as you are getting tall. Everything stays in proportion. And we call actually both these figures similar to one another, but we'll go into more detail with that later. So when you have a dilation, there's something called a scale factor. And the scale factor is how much larger or smaller you're getting. For a scale factor, we use the letter K. So we're going to change by the letter K. And that's just going to be a number. And some examples of K would be like, let's say K equals 2. That means everything is going to get twice as large. Everything is going to become double the size. Or if K equals 10, that means everything is getting 10 times as large. Everything is increasing by 10 times. Or you could have maybe getting smaller would mean like instead of doubling, you're going to become half the size. So K would be 1/2 then. Everything's going to get cut in half. Or K could equal 1/4. Everything will become 1/4 the size. So we can break it into different scenarios. Let's start with what an enlargement is. An enlargement, has it in the name, is when you're going to get larger. So an enlargement happens when we're going to get larger. Those are like K equals 2, K equals 10. Those are going to be when K is greater than 1. So whenever K is greater than 1, a larger number than 1, it's going to be an enlargement. So K equals 2, K equals 10. It doesn't have to be a whole number either. It could be K equals 4.5. It's still larger than 1. But you're getting 4.5 times larger. So that's what an enlargement is going to be. And we also have what we call a reduction. And a reduction is when you are reducing in size. So a reduction was like the K equals 1/2, the K equals 1/4. It's going to be when K is less than 1, but we're only going to have positive numbers. So it's going to be greater than 0. And these are all those numbers like K equals 1/2, K equals 1/4, K equals 3/4. It's still less than 1. So those are examples of what a reduction is. And some of our enlargements, we'll rewrite them. K equals 2, you're doubling. K equals 3 would be tripling. K equals 7.5, you're still getting 7.5 times larger. And the last thing, if K does somehow equal 1, that just means you're going to stay the exact same. So you're going to stay the same size. So same size. And if you put K equals 1 in up here, you're going to be left with XY, which is what you started with. So you're not going to get larger or smaller, you'll stay the same. So enlargements, they're what it look like over here. You go from smaller to being larger. A reduction, that would be like, have like a little square like this. And it's going to get smaller. It's just a smaller version of your original shape. So let's jump into some examples of these. Our first one, we have this little quadrilateral, parallelogram actually, on here on the coordinate plane. And we are changing by the scale factor of 3. So how we're going to do this is we're going to take our coordinates. I'm going to list them all out. And I'll list them out over here. We have P is -2, 1. We have Q is 3, 1. We have R is 2, -2. And S is -3, -2. And we are changing by the scale factor of 3. So that means you're going to multiply everything by 3. So changing by the scale factor of 3, and we'll list our new coordinates in our range. Your P prime, we still use the prime symbol. -2 times 3 is -6. -1 times 3 is, positive 1 times 3 is 3. our q prime, 3 times 3 is 9. 1 times 3 is 3. R prime, 2 times 3 is 6. Negative 2 times 3 is negative 6. And S prime is going to be negative 9, negative 6. Everything just got 3 times larger. When it comes to graphing that, well, we just graph the points that we just had. So negative 6, 3. Negative 3, 6, 1, 2, 3. That's going to be P prime. Q is going to be 9, 3. That's going to be Q prime. R is going to be 6, negative 6. Here we go. R prime. And S will be negative 9, negative 6. Here we go. And I'm going to go ahead and draw this in. And we'll actually look into some special things that happen with this. Here's our new shape. Everything got 3 times larger. When we're dilating about the origin. So everything is going to get 3 times further away from the origin. So like P was this far away from the origin, so P prime is now 3 times as far away. Some of the other things that pop up here, if you look at like our original shape, I'll use this. The distance from P to Q is 1, 2, 3, 4, 5 units. Since we got 3 times larger, the distance from P prime to Q prime is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 units. And that's because we got 3 times larger, so the distance between them will become 3 times larger. Those are some of the things that we're going to look into in the future. But for now, we just want to make sure that we can get the coordinates in the right spot. So we just have to know how to use that scale factor, multiply everything by 3. Let's look at our next one. We have this triangle. I'm going to slide it up right here. Here we go. We are changing by the scale factor of 1/2. K equals 1/2. So I'm going to list the coordinates, and then we're going to change by a scale factor of 1/2. So E is negative 2, 4. E is negative 2, 4. F is negative 2, negative 2. And G is 2, 4, 6, negative 2. And we are changing by this scale factor of 1/2. So K equals 1/2, meaning everything is going to become half the size. So E prime, half of negative 2 is negative 1, half of 4 is 2, half of negative 2, negative 1, half of negative 2 is negative 1, and for G prime, half of 6 is 3, half of negative 2 is negative 1. If you ever have, on a side note, if you ever have a scale factor of like K equals, let's just say 2/3, all you're doing is multiplying. Like let's say we did G here, you'd be doing 6 times 2/3, and you can like cancel out, you'd end up with 4 for that. And this one you'd end up with negative 4/3. You're just multiplying the scale factor by them. I'm just taking half here because I know how to work with the half, but if you have a fraction that you might not know how to do really quick, you're just multiplying, that's all you're doing. Alright, so let's graph our new points. Negative 1, 2. This is E prime. Negative 1, negative 1. This is F prime. And 3, negative 1. This is G prime. So this right here is our new triangle. This is the image. The red is our pre-image. The black here is our image. And everything is half the size. So all the coordinates are cut in half. Everything is going to be the same, half the distance away from the origin. So if you look at E and its distance to the origin, E prime is actually the halfway point there because the scale factor was 1/2. And if you were to count the sides, the distance from E to F is 1, 2, 3, 4, 5, 6. So the distance from E prime to F prime should be 1, 2, 3 because it should be half again, that scale factor, k equals 1/2. Alright, we're going to do one more, and then you can try some of these on your own. Here's our last one. We have, let's see, we have T, we have M, and we have H. This is our triangle, and we're going to change by a scale factor of 2. Now for this one, it's really important to know that the scale factor is in relation to the origin. So like I've been saying, everything is going to get 2 times further away from the origin. So let's look at our coordinates to start with. T is 1, 1. M is 3, 1. And H is 1, negative 3. Our scale factor is k equals 2. So that's what we're changing by, k equals 2, and we'll end in, let's go with purple. So T prime, everything is going to double, is going to become 2, 2. M prime is going to become 6, 2, and H prime will be going to become 2, negative 6. So if we go ahead and graph 2, 2, this is our T prime. M becomes 3, 6, 2. There's M prime. And H prime becomes 2, negative 2, 4, 6. There's your H prime. And let's trace over this one. I'll go in black. So here's your triangle. And this black triangle we have here, it is twice as big as the red triangle. It has changed by that scale factor of 2. So all the side lengths are going to be double the size. And your distance away from the origin is all going to be doubled. So like your distance that T was from the origin right here, now you can do 2 of those to get to T prime because you changed by the scale factor of 2. So the distance that H was away, well, you're going to do 2 of those, and you're going to get down here to H prime. Everything is twice the distance away. And the same thing happens for M. That was your distance, so you do that again. That gets you to M prime. Everything is double the distance away. But your final image is right here in this black. This would be your final image, that black triangle. And so right now all we're doing is just making sure we can get the coordinates, just change them by that scale factor, and we'll look into more of these properties in the future of how things change when you either enlarge or reduce an image. So go ahead and try some of these on your own. Have a nice day.